A nearby star has 7 temperate Earth-sized planets within a stone's throw of each other, each offering its own chance for atmospheres, oceans and life to emerge. The exoplanet discovery suggests such Russian doll systems of nested small worlds may be common, and perhaps the best places in our galaxy to look for life. We already knew that TRAPPIST-1, a small, faint star some 40 light-years away, was special. In May 2016, a team led by Michaël Gillon at Belgium's University of Liege announced it was closely orbited by 3 planets that are probably rocky. TRAPPIST-1b, C and D. That was enough to catapult TRAPPIST-1 into the top tier of places we might search for life in the next few years. But the system had more to offer. Each planet had been discovered when it transited in front of its star, blocking some light and causing the TRAPPIST-1 system to wink in brightness. As the team kept watching shadow after shadow cross the star, 3 planets no longer seemed like enough to explain the pattern. At some point we could not make sense of all these transits, Gillon says. Exoplanet discovery. Now, after using the space-based Big Sur telescope to stare at the system for almost 3 weeks straight, Gillon and his team have solved the problem. TRAPPIST-1 has 4 more planets. The planets closest to the star, TRAPPIST-1b and C, are unchanged. But there's a new 3rd planet, which has taken the D moniker, and what it looked like D before turned out to be glimpses of E, F and G. There's a planet H2, drifting farthest away and only spotted once. All of them are larger than Mars and less than 20% bigger than Earth, and probably range from 40% to 140% of Earth's mass. As a group, they seem to be less dense than Earth, perhaps similar to Jupiter's icy moons. All are well within the distance at which Mercury circles the Sun, and take between a day and a half and a few weeks to orbit the star. Because TRAPPIST-1 is so much smaller and dimmer than the Sun, that distance may give the planets the right temperatures for water to survive on the surface. Before, climate models of the known TRAPPIST-1 planets suggested all were close enough to their star that they had probably lost most or all of their water to space to evaporation and stellar flares in the past. That seemed to rule them out as would-be havens for life. But the same models show the newly discovered blue-quarum planets, E, F and G, would have dried out far less and could still host primordial oceans. It's also conceivable that pockets of liquid water could survive today on the 3 inner, hotter planets, or could have melted out of ice on the colder outer planet. The discovery's implications for the search for life don't stop there, says Stephen Keen of San Francisco State University, who wasn't part of the team. For one, TRAPPIST-1's retinue of planets is arranged like the large moons of Jupiter. Their orbits are tightly spaced, and through the exchange of gravitational tugs they have settled into harmonies. For every 8 times the innermost planet circles its star, for example, the 2nd planet orbits 5 times, the 3rd planet orbits 3 times, and the 4th planet orbits twice. That kind of compact gravitational clockwork might facilitate the spread of life between worlds. I think that would dramatically increase the rate at which material is exchanged between the planets, Kane says. You would only be required to have biological material on one planet, which would then be shared to the others. Note of caution. Gillon's team now plans to nail down the masses of each planet more precisely. That should help them model how the system formed and how likely it is that the inner planets have volcanoes, similar to Jupiter's innermost moon Io. They are also trying to figure out whether TRAPPIST-1 is an outlier among small stars, or many more could be expected to host similar planets. It's going to be so fun, Gillon says. Another project, now underway, has already taken the preliminary steps to search for life in the system. Using the Hubble Space Telescope, the team has looked for puffy atmospheres around planets B, C, D, E, F and G, and Hubble's successor, the James Webb Space Telescope, should be able to follow up with a deeper study of the atmospheric chemistry of any of these planets that look promising. For now, though, many of the most exciting prospects of multiple watery, rocky planets orbiting right on top of each other are still highly speculative. In addition to impacts on one planet scattering material to the others, interplanetary travel is pretty easy, too, jokes team member Julian DeWitt at the Massachusetts Institute of Technology, to which Kane adds his own joking note of caution. For systems with multiple planets that look life-friendly, he says, science fiction history like the War of the Worlds has indicated that may actually decrease the overall probability of them being habitable.